So this is the bubble wall, and what we have here is we've got a large tray that's filled with bubble solution. Now if you wanted to make bubble solution at home, all you really need is water, dishwashing soap, and a little bit of glycerin, and glycerin is what makes the soap solution a little bit stronger. We're going to start raising this bar, and this bar has little holes in it, so when it's filled up with a solution, as we start to raise it up, the solution is going to run down the strings and it's going to keep replenishing the bubble wall as it comes up. Now I've got it all the way up, and you see that we've got an entire screen here filled with the bubble solution running down and creating a giant wall of bubble solution. Now this string that you see here has a loop tied into it. As I reach my finger inside of this loop, it will pop, and when the little circle pops, you'll notice that it grows bigger. That's because of the surface tension of the bubble solution. It wants to contract. It wants to take up as little space as possible. So when the middle part breaks open, it is being stretched open by the bubble solution. You'll see that the strings along the side of the bubble wall are also bowing in, and when the solution pops, they bounce back out and go straight up and down. Again, that's because the bubble solution is wanting to contract and pull everything in to the smallest space possible. Before I go any further, a word about water. H2O, of course, is made up of 2 hydrogen atoms and 1 oxygen atom. Because of the way these atoms are bonded together, they share electrons unevenly. The distribution of the positive and negative charge, therefore, goes across from one side to the other. Scientists call this a polar molecule. So each water molecule has a partially negative charge near the oxygen atom and a partially positive charge near the hydrogen atoms. So when water molecules are close together, the positive charge of one molecule is weakly attracted to the negative charge of the other one. This attraction is called a hydrogen bond, and it means that the molecules would rather stick next to each other than to anything else. We call this cohesion, and the bubble wall will show us this. The hole that I've created here is being pulled open by the surface tension again, but it's large enough that I can actually reach my hand inside of it, and the entire area around it, that film is still not broken. What I'm going to do now is I'm going to create a giant wall again, but this time I've moved the string off to the side and I'm just going to blow to create as big a bubble as I can. You can see it here stretching out far beyond where the original wall was. Again, the bonding of the molecules here is strong enough to keep together. As long as the surface tension does not break, everything will stay together and create one long film. You can see this at home if you take a glass of water and fill it up just to the point where it's about to break over the sides. If you take a paper clip and gently place it on top of the water, the surface tension of the water will keep the paper clip up, and it will not break through and fall to the bottom of the glass. But if you break the surface tension with anything, such as the oil from your fingers, the entire surface film will break and the paper clip will fall through the glass to the very bottom. Here you see a water strider on top of the surface of the water. It can evenly keep its balance on top of the water and not break through the surface. This is similar to the paperclip I showed you earlier.